Hello, algebra students. Section 6 of the slope unit is about parallel and perpendicular lines. We've talked a little bit about parallel lines already, and we're going to extend that a little bit and also look at perpendicular lines. So a few things to note. Two distinct or different lines in a plane either something or are something. So think about two lines. They either intersect or are parallel. Those are our two options if they're in a plane. Parallel lines, how do they compare? They have the same slope. Perpendicular lines have opposite reciprocal slopes. An example of that would be if we have half, opposite reciprocal would be negative 2 over 1. So that's what opposite reciprocal means. So again, we have parallel lines, same slope, perpendicular lines, which meet at a 90-degree angle, opposite reciprocal slopes. All right, let's see what we can do with these. We want to write an equation of a parallel line. A line passes through 12, 5 and is parallel to the graph of y equals 2/3 x minus 1. We've been writing equations for a long time now. We know that we need slope and a point, or maybe an intercept. Okay, this is asking for slope-intercept form. So we have two options. We can write it in slope-intercept form, in which we'd have to find the b, or we can write it in point-slope form and convert it by solving for y. So first of all, we need a point, which we have, and we need a slope. Well, I know that I'm parallel to this line, and parallel lines have the same slope, so my slope must be 2/3. Okay, so I could go ahead and I'm going to just write it in slope-intercept form and find my b. Okay, so y equals m x plus b. Simplify those. So I have 8 here. Subtract 8. So b is -3. So my equation is y equals 2/3 x minus 3. So here is an equation parallel to this line, but also includes this point. All right? All right, here's the same question. Go ahead, try that one, pause the video, see if you can do it on your own. All right, so let's see if you did it correctly. Y equals m, same slope because they're still parallel, x plus b. This is -6, so I'm going to add 6. I get 5 as b. Y equals 2x plus 5. Again, this line is parallel to this line and goes through this point. Okay? All right, classifying lines. Are they graphs of 4y equals -5x plus 12 and y equals 4/5 x minus 8? Parallel, perpendicular, or neither, and why? Well, what do I need to be able to classify them as parallel or perpendicular? Slope. Well, I like this equation because it's in slope-intercept form, and I can tell right from looking at it that my slope is 4/5. This one, not so nice, but I know I can convert it to slope-intercept form, y equals mx plus b, very easily if I just go ahead and divide everything by 4. and I get y is negative 5 over 4x, so I did 5 over 4 this way, plus, and do 12 over 4, 3. So here, my slope is negative 5/4. So here are my two slopes. How do they compare? They look like opposite reciprocals to me, so they are perpendicular. Why? Opposite reciprocal slopes. You could go ahead and graph these on Desmos. They should create two lines that make a 90-degree angle. Okay? Similar to the other side where we wrote equations of parallel lines, we're just going to write equations of perpendicular lines. So what is the equation representing the line passing through 2, 4 and is perpendicular to this graph? Okay, well I can't just use this slope because I need it perpendicular, and perpendicular lines have opposite reciprocals, so I'm actually going to use negative 3 over 1 as my slope. And I'm going to do the same thing as before. So y equals mx plus b. 4 equals negative 6 plus b. Add 6. So b is 10. My equation y equals negative 3x plus 10. So again, this equation, perpendicular, meets at 90 degrees to this line here and goes through this point. Same kind of question here. Pause the video, try it on your own. Alright, since I want perpendicular, opposite reciprocal to 2. So my slope I'm going to have is negative half. Y equals m x plus b. So this is just negative half. So I'm going to add half. So 8 and 1/2 is b. So I have y equals negative 1/2 x plus 8 and 1/2. So one more time, this equation goes through this point and meets at 90 degrees or is perpendicular to this. Alright, let's put it all together. We can't just make it easy on you. Let's put a whole bunch of our skills together. A line passes through the points 3, 6, and 6, 4. Find an equation in slope-intercept form of the line that is perpendicular to this line and goes through 12, 10. Alright, so it's going to be very similar to these. The problem is, well, not a problem, but the only thing different is I can't just look at an equation to find my slope. I need slope to find something perpendicular. What do I have that would give me slope? I have 2 points. We know how to calculate slope from 2 points. 6 minus 4 and 3 minus 6 gives me 2 over negative 3. So that's my slope for this line. But I want an equation perpendicular to this. So opposite reciprocal of that would be a positive 3/2. So this is the slope I'm going to want to use. Now it's really just the same as this. I want to go through this point. So y equals mx plus b. That's 6. So I have 18 right here, so minus 18. Negative 8 equals b. So my equation then is y equals 3/2 x minus 8. So this equation goes through 12, 10 and is perpendicular to a line that goes through these 2 points.